Problem number 2b. Again, we're solving this quadratic. So I've got 2 times 3x minus 7 squared minus 63 equals 65. And I'm going to do it similarly to the problem we just did, number 2a. So I'm going to go ahead and move this constant over to the right-hand side. To do that, I've got to do a plus 63 on both sides. This cancels to 0. I drop down everything that's still on the left-hand side. And then I combine these. That will give me 128. Next thing I want to do is eliminate the coefficient here. How can I do that? I can divide both sides by 2. This cancels to 1, and 1 times what's left is what's left. So we've got 3x minus 7 squared equals 64. So 128 divided by 2 is 64. Okay, let's go ahead and square root both sides. So square root of the left side, square root of the right side. Good news. That's going to be a perfect square. Well, that is a perfect square. So the square root of anything squared is just that radicand itself. I've got 3x minus 7 equals 8, because the square root of 64 is 8. So now, don't forget, not only is it 8, but it's negative 8. This is how we're going to get our 2 answers. Because think about it, 8 times 8, 64. Negative times a negative, 8, also 64. And that's how we end up with 2 solutions. Now let's go ahead and separate our problems. So we're going to have 3x minus 7 equals 8, and 3x minus 7 equals negative 8. So we've got to account for both of these solutions of this right-hand side. Let's solve this and get our values for x. So I need to isolate the variable. That means I'm going to use inverse operations. Bring down 3x. This is going to give me 15. Divide both sides by 3. So my first value of x is going to be 5. Let's do the other side. So here I have same thing, plus 7, plus 7. These will cancel, bring down my 3x. And negative 8 and positive 7 is negative 1. When I divide both sides by 3, here we have our second solution is x is equal to negative 1/3. Let's take a look at number 3. Problem number 3. Now before I actually start working on problem number 3, there is one mistake that I need to correct for you. On this first problem, 3a, this 2 in the middle should have been a 21. So this should be a 21x. So I'm going to go ahead and put the 1 in there. And now we're going to work it out. And hopefully you notice that something wasn't right. Okay, so this is 5x squared plus 21x plus 4 equals 0. So for this section, I'm having you to match up each of these quadratic equations to their factored form only. You do not have to completely solve it. You just need to tell me what the factors are, because you're going to have a section of the quiz that asks you for that information. So, but we're still going to start it off as if we're solving them. So let's go ahead and go through the steps. Now notice that this first quadratic, the a is greater than 1. So we can apply the AC method that we learned about of factoring. So let's go ahead and do that. So we'll start as if we were going to work the problem out and solve it, but we'll stop at the factoring part and then match it up to whichever factors it fits. In this case, for the AC method, the first step that we would do is we would just bring down the first and the third term. You remember that? So that's the first step. And then AC of the AC method means multiply the A value times C value. In this case, the A value is 5, C is 4. So 5 times 4 gives me 20. What that means is I need to look at my factors of 20 and see which of those factors would give me 21 in the middle. Give me the B value. So my factors are 20 are 1 times 20, 2 times 10, 4 times 5. But when I add these, 1 and 20 give me 21. This gives me 12. This gives me 9. So here I've found my my two factors that I'm gonna use to break up that middle term, the x term, or the b value. So I'm gonna use 1x and 20x in order to replace them with the 21x. So I'm gonna put 1x plus 20x. So all I've done is I've written 21x as 1x plus 20x, which is 21x. And then the next step is to group them. Remember, grouping just means we put parentheses around the first two and the last two. Now, I do not need to go through the rest of the steps because I have found my two factors of this quadratic equation. They are, well, I'm sorry, no I haven't. I've got to go one more step. So I've got to actually factor. That means I need to find the greatest common factor for both of these and pull that out to the side. That means outside the parentheses. And I noticed that 5x squared plus 1x only have an x in common. So I'm gonna pull that x out, and what's gonna be left is the 5 and another x, because x times 5x is 5x squared plus 1, because x times 1 is 1x. So I factored the first group, now I need to factor the second group. What do 20x and 4 have in common? A 4. So I'm gonna pull that 4 out to the front of the parentheses. 4 divides 20x 5 times with the x, because 4 times 5x is 20x, and 4 divides itself 1 time. And do you recall that what's in parentheses should match? And they do. Now how do we actually write our two factors, our two expressions that go into parentheses? Remember, the outside terms makes up one of your parentheses, so the x that's on the outside plus the 4 that's on the outside makes up 1, and those matching expressions make up the second one. So these are the two factors of this quadratic. I almost stopped here, when actually I had not factored them out yet. So I'm looking for x plus 4, 5x plus 1. It's this one, so this is A. All right, we matched that one up. We didn't have to continue and solve for x, just that far. Let's do B. B is another one where we have a greater than 1. So we're gonna use the AC method, but first I need to get it in standard form, because notice it's not equal to 0. That means I need to move this over. I'm gonna put it right up under the 7x because they are like terms. It cancels from over here. I bring down my 3x squared. This will become 4x plus 5, and I have 4 still left, so I gotta get rid of the 4, because remember, we're trying to put it in standard form, which means we want 0. So I'm going to subtract 4. Whatever I do over there, I gotta do over here. So now I've got 0 equals, this will give me 1, bring everything else down. All right, plus 1. All right, now, let's apply the AC method. We haven't done it yet. All we've done is put it in standard form. I'm gonna move this out here to give me a little bit of room. So the 3x squared plus 4x plus 1 equals 0. First thing we do, drop down the first and the third term. So I'm gonna bring down my plus 1 equals 0. And I need to break this apart. But remember, the AC method means A times C. 3 times 1 is 3. So I need factors of 3 that will add up to 4. Well, there's only 2 factors of 3 because it is a prime number. When I add those, I do get 4. So I can break this 4x up into 1x and 3x. And that does equal 4x. Let's group them. Group, 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 okay? And now I need to factor. So what do 3x squared and 1x have in common? Just an x. So I'm gonna pull that out. What's left from here? 3x. What's left from here? 1. And now let's do the same here. What do 3x plus 1 have in common? Well, nothing that I can see, so it's 1. 1 goes into everything. So I'm gonna pull the 1 out. What's left? Well, 1 times 3x would take me back to 3x, and 1 times 1 would take me back to that 1. Now notice, these do match. Those inside parentheses terms, expressions should match, and they do. So how do we set up our two factors? The outside term, so the x plus 1 is the first factor, or one factor, and the matching terms, the 3x plus 1 is the other. So I'm looking for this, x plus 1 and 3x plus 1. So this is B down here. Okay, let's get these. Now luckily this is x is equal to 1, so this one's pretty easy to factor. We don't need to use the AC method. Let's just break them apart into their two parentheses. I think we should be able to find them. So x and x. And if I list my factors of -4, let's see, -1 times 4, -2 times 2. Will any of these work? If I add these, this will give me 3, this will give me 0. I need 3, so this is what I'm looking for. So I'm looking for -1 and +4. Let's see. That would be this one. X minus 1, x plus 4. Oh, that was quick and easy. All right, D. Now, do you notice that this is a difference of squares? We could use that method. How do I know? Because difference means subtract, and we've got two perfect squares. So let's break it apart. And if you recall, that method says that you want to ensure that you've got a plus and a minus when you break them apart. So break up the x, you get x and x. 64 is perfect, that's why we can use that method, and it will give us 8 times 8. So we're looking for this one, and that's here. That matches with D. And of course, the other one has to be E, but let's take a look at it anyway. So here, when we break this up, this is also a difference of squares problem, because it's subtraction, that's the word difference, and we've got perfect square here, perfect square here. The square root of 25 is 5, and 5, break up the x squared, x, and then the square root of 81 is 9. So +9 and a -9. Those are the two factors, and it does fit that one. All right, let's look at problem number 4. All right, let's do problem number 4, the last problem. Well, the last two, because I broke it into part A and B, but this is pretty short, and this ends this rounds up the study guide. Number 4 asks what value of C should be added to both sides of the equations to complete the square. So we're talking about the complete the square method, and it has several steps, but there's one step in particular that we want you to focus on and we want you to think about. When we do completing the square, there's a step that says that we need to divide the B term, which is the x term. Remember, you got your A, your B, and your C when it's in standard form. So we're going to divide that by 2 and then square that value. And this is what we're talking about. So this is all we're going to require for you for this particular assessment, just to make sure you know that part. Because whatever you get when you square that value, that's what you will add to both sides of the equal sign in the completing the square method. Of course, we would also group the variables on one side and the constant would be moved to the other side. But what would I be adding to both sides? Well, here's the x term, the B value. So what I would do is divide this by 2, which will give me 7. And then I would square the 7, which is 49. So in answer to this question, what value of C should be added to both sides of the equation to complete the square? For this problem, 49. Okay, let's take a look at this one. And that's all we're asking. We're not asking for you to completely solve it. Just checking to see if you can figure out that particular step. For this one, same thing. So here's the x term, or the B value, divided by 2. That will equal 5. And then square that 5 and you will get 25. This would be the value that you would add to both sides of the equation. All right, and at this time, I'm not going to go through the entire completing the square process. We'll just stick to that step that you're gonna need in order to work on your quiz, your assessment next week. All right? All right, that is it. Good luck on the quiz.